Hello everyone, myself Dr. Feroza Demirajkar, and today we will see a 8051 program to find the cube of a 8-bit number by using loop method. Earlier I have shown you a program to find the cube of a 8-bit number without using a loop method. Here the logic of the program remains same. I will provide the description link of the previous program in the description box. So to understand the logic, you can go through that program. Here we'll take a number ff for which we want to calculate or compute the cube. So what we have to do is we have to multiply the same number thrice in order to find out the cube of the number. So here I'll take ff, I'll then multiply it with ff. We will get fe01. This is nothing but the square of ff. Now we have to multiply the product of this with again ff. So this number fe01, it cannot be directly multiplied with ff because here it is a 16-bit and this is 8-bit. So here what we have to do is first we have to multiply ff with 01. We have to find out the product. Next we have to multiply ff with fe and get the product. So when we multiply ff with 01, we get 00ff. When we multiply ff with fe, we get fd02. Then we'll add these two, we get fd02ff. This is nothing but the cube of ff. This is the link which I will provide you in the description box. These are the steps to perform the or to calculate the cube of the number. So here first we will initialize the registers, then we will be loading the values. We will be multiplying the values from the registers, and we'll be calling a subroutine which is called given the name as cube. Then we are having a loop in order to calculate the cube of the number. Here we'll be using some conditional logic instructions, and we will be incrementing the pointers, that is the memory pointers, and we'll be finding the cube of the number. Okay, so first is the initialization process, that is the initialization step. Here we have org000h, which will set the origin of the program to address 0000h. Then we have move r0 comma hash 30h. Here it will load the immediate value 30h into the register r0, and the register will point to the memory location where the first operand is stored. Then we have move r1 comma 31h. Okay, here so here it will load the immediate value 31h into the register r1, and this register will point to the memory location where the second operand will be stored. Right. So what we have done here is we have started our program by setting the origin to 0000h. Then we have loaded the value 30h into r0 and 31h into r1, and this is the initialization step. Next we have loading values and the multiplication. So here the first instruction is move a comma at r0. This will move the value stored at the memory location pointed to by r0, that is 30h, into the accumulator a. Okay, here in our program we are loading r0 by 30h. Next instruction is move b comma a. This will copy the value from a into register b. Then we have MUL AB, which will multiply the values in the accumulator and the b register, and the result will be stored in the accumulator and the register b, where the accumulator will have the lower byte and the register b will be having the higher byte. So what we have done here, we have loaded the value from the memory into the accumulator. Then we have moved the value from the accumulator to register b, and we will multiply a and b, and we will be storing the lower byte in the accumulator and higher byte in the register b. Then we will call the cube subroutine. So here first instruction is L call cube. This will call the subroutine which is labeled as cube to compute the cube of the value which is in the B register. Then we use H colon S jump H. This will create an infinite loop and it will halt the further execution after the cube calculation. So what we are doing here, we are initiating a subroutine call and we will execute the cube subroutine and then we will enter a infinite loop in order to stop the program. Now we'll see the cube subroutine. So here the label is cube. Then we have move R3 comma B. This will store the value of B, that is the result of the multiplication, into the register R3 for the later use. Then we have move R2 comma hash 02, which will initialize R2 with the value 2, which will be used as a counter for the loop. So here we are using two move instructions and the registers used are R2 and R3. This is required for the cube subroutine. Now we'll see the loop for the cube calculation. Here we have up. We have given the label as up to start the loop. First instruction is move B comma at R0. Here it will load the value from the memory location pointed to by R0 into the B register. Then we have MUL AB. So it will multiply the values in A and B again. Then we have add A comma at R1, which will add the value at the memory location pointed to by R1 to A. Then we have move at R1 comma A. It will store back the result into the memory location pointed by R1. So what we are doing here, we are moving the value to the register. Then we are multiplying the values from the registers and we are adding the value to the register and we are moving the value to the memory. Now we'll see about the conditional logic. So here first is JNCD, that is jump to label D if there is no carry from the previous addition. Then increment R1. This will increment the R1 to point to the next memory location. Then we have increment at R1, which will increment the value at the memory location pointed to by R1. Then we have decrement R1. So here decrement R1, it will get back to its previous value. Next is delabel. Okay, this is for the next code. So here we have increment R1, that is we'll increment R1 again and we'll move the content of B into the accumulator and we will add the value at R1 to the accumulator and then we'll store back the result into the memory location pointed to by R1. And next instruction is JNC D1. This will jump to the label D1 if there is no carry. Okay, here it will move. If there is a carry, then it will increment R1 and it will increment at R1, that is it will increment the value at the memory location pointed to by R1 and then it will decrement R1 to its back to its previous value. Okay, and here move A comma R3. Here it will move the original value from R3 back into the accumulator. Then it will check for the value of R2. If it is 0, then again it will go back to the location up. Okay, and then it will return from the subroutine here for RT. Now what we are doing here, we are using jump if no carry. We are incrementing the register, then we are moving the data. Okay, and here we are moving the data and we are adding the values. Okay, and we are storing the results. And here we are using some conditional jump instructions and we are moving the values into the registers and we are decrementing. We are using the decrementing operation instructions here and we are using a return instruction to return back to the main program. So overall what we have done here is we have initialized the registers and the memory. Then we have performed certain multiplication operations and we have used a subroutine which is labeled as cube. We'll call that subroutine, and within that we have a loop which will execute the logic to calculate the cube, and there we have a main loop also. Okay. So once the cube logic is completed, then it will enter the main loop. This is the program. Okay. Here in the previous slide, up was not there, no? Here DJNZ R2 comma up. So up is here. Okay. It will go to this. I have taken one example here. If at 30H we are giving FF, then at 31H, 32H, 33H, you should get the output as FD0 to FF, that is the cube. And here 30H, at 30H we are giving 3. After the first multiplication, you should get A as 9 and B as 0. Okay. Now again we have to multiply 3 to this 9, we'll get 27. Okay. So we'll be storing the result in 31H and 32H. So 31H will be having 1B, that is the lower byte of the 27 in hexadecimal, and 32 will be having 00, that is a higher byte of 27 in the hexadecimal. You can try for other inputs also. Another input which I have taken is 08. Okay, here after the multiplication, that is after finding the square, you will get 40H in the lower byte, at 00H in the higher byte. Then when again you multiply this with 08H, that is 40H is multiplied with 08H, you get 0200, that is 512 in decimal. So this is how you store the result. At 31H you will get 00, at 32H you will get 02, and at 33H you will be getting 00. Okay. Now we'll execute our program. We'll open Keel software. So now here we'll go to project, new MU Vision project. I'll use the previously used project, that is Alice, save S. Now I'll search the microchip device. I'll click on the plus symbol and I'll search for 8089C51. Okay. And click on no. Now go to file, new file. You have to type your program here. I'll paste the program. Then I'll save it. I'll save it as cube. Already one cube program is there. I'll save it as cube1.asm. Save. Now you have to go to target. You have to click on this plus symbol. You'll get source group 1. Right click on this and click on add existing files to source group 1 and search for your program. It is cube1.asm. Add, close. Okay. Now you have to see whether it has been added. It has been added. Go to project, build target. So there are 0 errors and 0 warnings. Now go to debug, start or stop debug session and click on OK. Now here we have to take memory 1 window, I:30H, enter. At 30H you have to give the input as FF. Okay. Now you have to check for the output, run. So you are getting FF02FD. Okay, this was the output. That is, this is the expected output which we have to get. So hope you have understood the program. Thank you.